Dear students, today we are going to solve numerical problems from interference of light. At first, let us review the related formulas. This is the diagram showing Young's two-slit experiment where S is monochromatic source of light. Two equidistant slits A and B act as coherent sources, and this is a screen placed at distance capital D from AB and parallel to AB. Due to constructive and destructive interference, the alternate bright and dark fringes are observed on the screen, the central fringe on the screen being bright. For distance of nth bright fringe from center is given by the relation XN is equal to N d lambda upon d, where d is the slit separation, means separation between two slits A and B. Similarly, distance of nth dark fringe from center is odd multiple of Similarly, the distance of nth dark fringe from center of screen is given by xn is equal to 2n minus 1 into lambda d upon 2d, where n is 1, 2, 3 and so on integer. Fringe width beta is equal to width of a bright or dark fringe is equal to lambda d upon d, where lambda is the wavelength of light used and d is slit separation. Condition for constructive interference is that the path difference between two rays coming from coherent sources must be integral multiple of wavelength lambda. That is, path difference is equal to n lambda, where n is integer 1, 2, 3 and so on. Similarly, condition for destructive interference is path difference must be odd multiple of lambda by 2, where lambda is n is 1, 2, 3 and so on. When apparatus is immersed in a liquid of refractive index mu, then the wavelength becomes lambda upon mu. Therefore, the fringe width becomes beta dash is equal to lambda d upon mu into d. Angular width theta is equal to beta upon d, which is equal to lambda upon small d, is the angle made by the central bright fringe at the slits. First problem. In Young's two-slit experiment, the separation of the first 5 fringes is 2.5 millimeter. When the wavelength used is 620 nanometer, the distance from slits to screen is 80 cm. Find the separation of two slits. Solution. Here, suppose this is center of screen. This is central bright fringe. This is dark fringe. Again, bright fringe, dark fringe, bright fringe. 1, 2, 3, 4, 5. This is bright, dark, bright, dark, bright. So, in first 5 fringes, there are 1, 2 and 3 bright fringes. In first 5 fringes, there are 3 bright fringes. Therefore, x3 will be equal to x3 will be equal to 2.5 into 10 to minus 3 meter, 2.5 millimeter. Here D is 80 cm is 0.8 meter, lambda is 620 nanometer, means 620 into 10 to minus 9 meter. We have to find D, which is slits separation. Now x3 is equal to, or xn is equal to n lambda d upon d. Therefore x3 will be equal to 3 lambda d upon d, which gives d is equal to 3 lambda d upon x3. We get 3 lambda is 620 into 10 to minus 9 into d 0.8 upon x3 is 2.5 into 10 to minus 3. Therefore we get d is equal to 5.95 into 10 to minus 4 meter. Question number 2. In Young's two-slit experiment, two slits spaced 0.45 millimeter are at 75 cm distance from the screen. What is the distance between second and third dark lines if the wavelength of light is 500 nm? Solution to question 2. We have to find the distance between second and third dark lines. Dark lines means dark fringes. Between second and third dark lines there will be one bright fringe, that is width of a bright fringe is equal to beta is equal to lambda d by small d. Therefore beta will be equal to, lambda is 500 nm, 500 into 10 to minus 9 meter, d is 25 cm, 0.75 meter, and small d 0.45 millimeter, 0.45 into 10 to minus 3 meter. So we get beta is 8.33 into 10 to minus 4 meter. Next question number 3. In Young's two-slit experiment, the separation of the 4 bright fringes is 2.5 millimeter when wavelength of light used is 6.2 into 10 to minus 7 meter and the screen is at 80 cm from the slits. Find slits separation. Solution to question 3. Separation of 4 bright fringes means here x4 is equal to 2.5 millimeter. 5 millimeter means 10 to minus 3 meter. This is separation of 4 bright fringes. Lambda is equal to 6.2 into 10 to minus 7 meter and screen is at 80 cm. So d is equal to 0.8 meter. Find the slits separation. We have to find D. Slits separation. Now XN is equal to N lambda D upon D, which gives D as N lambda D by X N. Therefore, D will be equal to, here N is 4, so 4 lambda D by X4. 4 lambda is 6.2 into 10 to minus 7. D is 0.8. X4 is 2.5 into 10 to minus 3. So we 7.9 into 10 to minus 4 meter. Now fourth question. The distance between two coherent sources in Young's two-slit experiment is 0.3 millimeter and the interference pattern is observed on screen at 60 cm from the sources. If the wavelength of light used is 6 into 10 to minus 7 meter, find fringe width. Here solution. Capital D is 0.6 meter. Wavelength lambda is 6 into 10 to minus 7 meter. Slits separation is 0.3 millimeter, means 10 to minus into 10 to minus 3 meter. We have to find fringe width. We know beta is equal to lambda D by D. Therefore, lambda is 6 into 10 to minus 7. D is 0.6. Small d is 0.3 into 10 to minus 3, which gives 1.2 into 10 to minus 3 meter. Next question number 6. In Young's double slit experiment, the slits are 0.03 millimeter, 0.03 centimeter apart, and the screen is 1.5 meter away. The distance between central bright fringe and fourth bright fringe is 1 cm. Find the wavelength of light used. Solution to question 6. Given in Young's double slit experiment, slits are 0.03 cm apart, means 0.03 into 10 to minus 2 meter slit separation. Distance of the screen is 1.5 meter. Fourth bright fringe is X4 is equal to 1 cm, that is 1 into 10 to minus 2 meter. What is wavelength? Now X4 will be equal to 4 lambda D by small d. Therefore, lambda will be equal to D into X4 divided by 4D. Value is D is 0.03 into 10 to minus 2. X4 is 1 into 10 to minus 2 upon 4. D is 1.5. We get next question number 7. Two coherent sources A and B of radio waves are 5 meter apart. Each source emits waves of wavelength 6 meter. Consider points along the line between two sources at which the distance, at what distance, if any, from A, the interference is constructive. Solution to question 7. Here, suppose these are two coherent sources A and B at distance 5 meter. Wavelength emitted by each is 6 meter. We have to find a point at which interference pattern is constructive. Interference pattern will be constructive if the path difference is 0. At midpoint, C, suppose this is C, the path difference बराबर AC minus BC will be 0. Therefore, point C will be at constructive interference. Therefore, AC will be equal to 5 by 2 is equal to 2.5 meter. Next question number 8. In Young's double slit experiment, the distance of 10th bright fringe on either side of center of interference pattern is 3.44 cm. The distance of a screen from the slits is 2 meter and wavelength of light used is 5.89 into 10 to minus 7 meter. Find slit separation and the angle made by the central bright fringe at the slits. Solution. Here, distance of 10th bright fringe is 3.44 cm means 10 to minus 2 meter. Distance of screen from slits is 2 meter and wavelength 5.89 into 10 to minus 7 meter. First we have to find slits separation and second angle made by central bright fringe at slits. Now solution first. For nth bright fringe, x n is equal to n lambda d upon small d. Therefore, x10 will be equal to 10 lambda d upon small d, which gives small d as 10 lambda d upon x10. 10 lambda is 5.89 into 10 to minus 7 into capital D is 2, x10 is 3.44 into 10 to minus 2. So we get 3.42 into 10 to minus 4 meter. Now second part, theta is equal to beta upon d, which is lambda d upon d, that is lambda upon small d. Lambda is 3.89 10 to minus 7 upon d is 3.42 into 10 to minus 4, which gives 1.72 into 10 to minus 3 radian. 1.72 into 10 to minus 3 radian. Next question number 9. In Young's double slit experiment, d is equal to small d is equal to 0.3 millimeter, capital D 30 cm, wavelength lambda 590 nanometer. Find the fringe width when apparatus is immersed in water of refractive index 1.33. Solution to question 9. In water, new wavelength will become lambda upon mu of water. Lambda is 590 into 10 to minus 9 meter upon 1.33. Therefore, fringe width beta dash will be equal to lambda dash d upon small d. Lambda dash is 590 into 10 to minus 9 upon 1.33 into d. D is 30 cm is 0.3 meter upon small d. Small d is 0.3 millimeter means 10 to minus 3 meter, which gives beta dash as 4.44 into 10 to minus 4 meter. Next question number 10. A light source emits lights of wavelengths 4300 angstrom and 5100 angstrom in Young's double slit experiment, where small d is 0.25 millimeter and capital D is 1.5 meter. Find the separation of third order bright fringes due to two wavelengths. Solution to question 10. For third bright fringe, x3 will be equal to 3 lambda d upon d. Therefore, delta x3 will be equal to 3 d upon small d. Delta lambda means lambda 2 minus lambda 1. So delta x3 will be equal to 3 into capital D is 1.5, small d is 0.25 into 10 to minus 3 into lambda 2 minus lambda 1. Lambda 2 is 5100 minus lambda 1 is 4300 angstrom means 10 to minus 10. So we get delta x3 as 1.44 into 10 to minus 2 meter, because 1 angstrom is equal to 10 to minus 10 meter.